All right, let's talk about section 6.3, which is inverse functions. So I'm going to give you a definition. This is how I think about inverse functions. Let f of x be a function that sends x to y. All right, so my x's go to my y's. Here's x1 goes to y1. Here's x2 goes to y2, etc. G is an inverse function of f if G sends every y back to the original x. All right, so moving this way is f. And if I move back this way through G, and it always goes back to the same point, then G is an inverse function for f. Another way to say that is x goes through the f function, and you get a y. If you then send, so let's give these a little bit more specific. So I think of these as being specific, but they may not be to you. So x1 goes to y1. If I then send y1 through my g function and I get back to x1, then that's an inverse. So this has to be true for all xy pairs. And not only that, if I start with my y's and I send them through my g function to get x's, then when I send them back through my f function, I have to get back to the y's. So g undoes what f does, and f undoes what g does. You have to work both ways. Whether you start with y's and go through g and then back to y, or if you start with x's and go through f and then back to x's, it has to work in both directions. So let me just give you a couple examples. Log base 3 is the inverse, let's see, function for exponential with base 3. So if f of x is 3 to the x, then log base 3 of y is the inverse. X goes through f, gives me 3 to the x, goes through log base 3, gives me back x, right? Because x is the power that goes on 3 to give me y, gives me an x. And importantly, if I do log base 3, if I start with y and I go through my log base 3 function, I get log base 3 of y, and now if I put that through my f function, I end up with y again. So in your table, you've done this a couple times. Let me just, or you will do this a couple times in your homework. So let's let this f of x equals 3 to the x, and g of y equals log base 3 of y. You'll notice I'm still using y's and not x's. That's because I like to think about f sends my x's into the y space and g sends my y's into the x space. I'm not just looping. Let me start over here, add a little bit. Okay, so if x equals 1, and then this is 3, and this one is log base 3 of 3, which is 1. And if x equals 2, this is 3 squared, which is 9, and log base 3 of 9 is 2. If x equals 0, that's 3 to the 0, which is 1, and log base 3 of 1 is 0. If x is 4, 3 to the 4th is 81, and log base 3 of 81 is 4. So I'm starting with x, I'm running it through f, and then I run it through g, and I get back to where I started. 2 goes to 9, then back to 2. 0 goes to 1, then back to 0. And it'll work the other way as well. If I have y here, and I have log base 3 of y, and then I have e to the x here, or sorry, 3 to the x. So if y is 5, so log base 3 of 5, that's not right. Let's do 243, there we go. Log base 3 of 243 is the power you put on 3 to get that number, which is 5. And 3 to the 5th is 243. If y is 1, log base 3 of 1 is the power that goes on 3 to get 1, that's 0, and 3 to the 0 is 1. If y is 27, log base 3 of 27 is the power that goes on 3 to get 27, that happens to be 3. 3 cubed is 27. And we can see that we start here with the number, we run it through our log function, and then we run it through our exponential function, and we get back where we started. We can write this as a composition. So f and g are inverses if f composed with g of y, which is f of g of y, is just y. You start with y, you end with y. You start with y, you end with y. And g composed with f of x, which is g of x, inside of f is x. You start with x, you end with x. You start with x, you end with x. So this is the definition that's in your notebook, except the definition in your notebook uses x's here instead of y's, but I prefer to use a different domain to help me keep track. So now let's just talk about types of inverse functions. So if I list my functions here and my inverses here, I'm just gonna make a nice long table. So let's start with the ones we know. E to the x, the inverse is natural log. I'm still going to use y, but you'll see natural log of x. 3 to the x, log base 3 of y. X squared, square root of y. How do you undo the square? You take the square root. X cubed, cube root of y. X to the 5/7, y to the 7/5. I can write radicals as fractional exponents. So for a power, you just use the reciprocal. The reciprocal of 2 is 1/2. The reciprocal of 3 is 1/3. The reciprocal of 5/7 is 7/5. If I have the 9th root of x, that's like x to the 1/9. That's just y to the 9th. if I have log base 10 of x, that's 10 to the y. All of these are just the inverse functions. We have to be a little bit careful, and I'll talk about this in a minute with x squared, because of what x squared looks like and because of what cube root of y looks like. But we'll be okay. Other ones, there are some real basic ones like a linear function. So how about just f of x equals 3x? Then here it's just 1/3 y. It's just the reciprocal. If I have 5x minus 2, then this would be y plus 2 divided by 5. So coming up, especially for linear, you've done this a lot when you're solving, right? If 3x equals y, then 1/3 y equals x. If 5x minus 2 equals y, then you add 2, and then you divide by 5, and you get this one here. An inverse function just takes you back to where you started. Any others that I can think of? I think these are all the ones we cover. Okay, so let's look a little bit more deeply at x squared. X squared and its inverse. So first of all, x squared, which looks like this, can take all real numbers. All right, I can do 3 squared, which is 9. I can also do -3 squared, which is also 9. The square root of y looks like this, and this is only 0 up to infinity, because I can do the square root of 9, which is 3, but I can't do the square root of -9. So when we think about inverses with something like this x squared function, even powers in particular, if I think of it as a composition and I want to compose f of x equals x squared and g of y equals the square root of y, if I do f composed with g of y, I have the square root of y, that's my g, and then I square it, and that just gets me back to y. That works really well. But if I do g composed with f of x, that's x squared in the square root, and that equals 2 values. That equals x, and that equals 1 value, which is x if x was positive, and it equals minus x if x is negative. Let me show you what that means. So if I do, let me rewrite it up here, f of x equals x squared, g of y equals square root of y. Let's do g composed with f of -2. Well, that's -2 squared in the square root, which is the square root of 4, which is 2. And this number is not the same as that number. So the lesson there is be careful with even powers and inverses. Because an even power can take a negative number and make it positive, and that means you don't get back to where you started. This is going to matter in particular in section 7.1. It's not going to matter so much in this section, but I just wanted to call that to your attention now. All right, that's the end of this video.